This is Mick Elliott from Electronic Specifier. I am on the analog devices stand at Embedded World. This is Louis, who may have actually the best job in the show at the moment. However, obviously there is a serious side to why Louis is lying on this bed. To find out, we'll speak to Irene Pastor from Analog Devices. Irene, can you just describe what's happening here?
So, here this small white box that we have here, it's one of the non-contact vital sign monitoring modules. And this teeny tiny box is embedded in between the mattresses, like a bit far from the patient, so it's barely noticeable. And the purpose of this module that contains ADXL ultra low noise with a microcontroller that also has wireless capabilities like Bluetooth and a coin cell section for battery powered applications. And with this, we use the ballistocardiography principle. Basically, the forces that your blood through your veins when pumping, it expands and collapses, and that vibration gets extrapolated to the mattress, and we measure that with our ultra-low noise accelerometer. And then we are able to extract the three vitals that you see here. The yellow one is the heart rate, the red one is a computed part of the yellow part, so it's the heart rate variability, and the green one is the respiration rate. So if Blue is deep breathing or has a higher heart rate, then we will see it. The perfect use case for this is like hospital patient monitoring or elderly home, so that it makes life easier for the nurses and the assistants home living, for example, where we extract all the necessary information to optimize the time and the people around the caring space, right? And the good news from last time we presented this demo is that we recently went through our validation study, 2 sleep studies, and it looks like very promising, and hopefully we have like nice accuracy report results in the coming months with more information. So non-contact vital sign monitoring.
Okay. Just give us a bit more about the Analog Devices technology behind this, and also maybe I think one of the things is, as you say, there's data there. How it's possible to save it, and obviously security as well.
So for now, the key highlights here are the accelerometer, the sensor, because it's ultra low noise and it's capable to work in a 2G range, which is like the low range of G forces that we need to acquire to measure the vitals. And then also the algorithm. So with the help of the Analog Garage group inside Analog Devices, we are able to have this kind of machine learning algorithm and extract not only these vitals, but even more potentially in the future also. And those are the key points here in the demo. Nonetheless, we have been discussing potentially adding authenticators and security encryption parts like the ones we see later to ensure there's patient information protected and it's all robust and consistent. So it will keep the data secure and the information of private patients also secure.
There's a microcontroller at the heart of this.
Yeah, the microcontroller is not Analog Devices, that's currently, but we are currently looking into potentially moving into a Maxim microcontroller since the acquisition. Also potentially looking into the Maxim 800, which is our AI convolutional network accelerator-based microcontroller, in order to process the information that we get there to do a bit more diagnostics and potential like detection of what's going to happen. So we add on the AI capabilities there, and then we would have like a proper system in place for medical diagnostics kind of. But we're not there yet.
Okay. It might sound like a silly question, but does it have to be a type of bed to accommodate this in terms, I'm just thinking of the thickness of the mattress or whatever?
So, of course, depending on the distance where you place it, we will have to, the filtering may vary, but we have tested the module even on the bottom of the bed by the feet, and we were still able to measure. Because of the ballistocardiography principle, the forces get expanded throughout the entire structure, so any point of vibration, it's going to be sensitive enough to capture the data. Of course, there are places where the signal is going to be stronger, hence where we focus right now, the chest area. But also, like if I hit the bed, Like, for example, I'm going to saturate the sensor, and then it's going to say, oh, something happened. This could also be useful for simulating if someone is falling from the bed or someone is moving and tilting and changing position. So you can also do a bit of sleep analysis afterwards with this.
You mentioned the study, so where do we stand now in terms of rolling this out?
We're waiting for that report to come out, and then we will probably use that as our kind of like a preliminary data sheet, kind of to report the accuracy with respect to the vitals, right? We don't want to go around saying like, yeah, we're as accurate as a reference system without the actual numbers. So with that, it's setting the basis for let's say, a preliminary product, right? Then the other thing is like we're looking for healthcare enablers or elderly care kind of partners to build the business enough to bring this to everybody as soon as possible. Also tune as much as we can. For example, on definitive applications like sleep analysis, like are we going to look into sleep apnea fully, or are we going to go more into epilepsy study? Elderly more monitoring kind of. This is where we want to wait a bit, and that's why we have the flexibility with the microcontroller and the interface to ensure that anybody that wants to do business with that comes to us, and then we lock it. Kind of.
Just supposing I'm running a care home for the elderly, for people like me, and
you're young.
no, it's a care home, and I think, yeah, this really works for me. So I use the sensor in, say, 20 of the beds in the care home. How can I see all that on one screen?
So actually, Analog Devices now has part of remote patient monitoring kind of section inside the digital healthcare group, and that's where we're trying to build these dashboard kind of setups where multiple sensors, either from Analog or third parties, come together. We combine and collect the information, and it's kind of simulating the telemedicine system, right? So we are already stepping into actually providing help with these kind of services that we see our customers potentially facing, right? So that could be the way to go, but it's the partner team, so to say.
Because I'm just thinking, in a care home situation or whatever, if I could maybe pick the data up on my telephone, or an alert comes on the telephone.
Yeah. So yeah, of course, like if it's more on the consumer data, so let's say, right, an app application is going to be probably the best way to go. If we're doing an elderly home where it's multiple rooms, multiple patients, you want to bring all that information into one single dashboard, not only on the phone. Or fine, a big dashboard that is accessible through the apps, the same. It's not a single end kind of person-to-person information. It's more like your home caretaker has the entire information, and then they can see, okay, I need to pop by room 320 because the person has not been moving for a while, so let's go massage and like check and so on, kind of rehabilitate also. That could be also another rehab centers with people that cannot move.
Okay, well there you have it. That's the vital signs monitoring solution from Analog Devices, and thank you very much, Irene Pastor.
Thank you, and if you have more information, come reach out to us.